All right, thank you, folks. My name is Maya. I work in the Linux system group at Microsoft. Now, I did notice that I'm going to be one of the first of the three talks on sysext and confext. So this is clearly the year of the Linux extension images, and I'm very happy to be opening it. This is joint work with my colleague Maya, who also works in LSD at Microsoft, who is not here today. Both of us kind of got our start being first-time systemd contributors working on confext. So happy to share more about what has been done over the past 2 years and what confext looks like. So just to quickly recap for folks who are not familiar, or if you found this talk on Google, systemd-confext basically lets you override /etc by allowing you to basically just drop extension bundles, and then it will automatically apply it all using overlay fs. So a very rough diagram just to give you an idea, right? You have your base file system that is in the yellow. So you have some existing files like the config.ini there. And then if you dropped in a .raw file that is in the green box over there, and you run systemd-confext merge command line, and the result is that you'll get all the new files that you've added. And if there are files with the same name, then you will always get the newest version, which is kind of about what you expect. And being part of the systemd ecosystem definitely has its benefits. For example, systemd-confext shares code with the DDI introspection in the rest of the systemd code base, which means that you get variety signed images. You can definitely use them like that. Or you can have extensions that are scoped to specific services, right? So this is using the extension images equals clause. So you don't have to have the extension applied to the entire file system if you don't want to, and we'll talk a little bit about that later. So you can see confext is something that is really helpful if you have an image-based file system. One of the first non-commercial uses of confext that I've heard of is I met someone the other day who really wanted to code on her Steam Deck, and so they use sysext and confext to basically get VS Code on there. At Microsoft we run a Yocto-based image-based file system, image-based OS. And very early on, we found out that if you want to update a single configuration file, you have to rebuild the entire system, and then to actually get it out to production, then the release cycle takes a few more months as well. Luca has a talk given in this venue back in 2023 if you want to learn more about it. But the main lesson is that, and you will see this in a couple of talks following this one, is that there is some of a gap between making a new config file, making a new extension image, and actually getting it applied onto the system. And confext hopefully bridges a little bit of that gap. For us, confext is nice because it prevents us from having to, run a million mount commands on each individual system, and instead you get this nifty tool that mounts the extension on the host and then sets up the overlays for you, and then you get some nice benefits, like they are atomic, and I will talk about this right in the next slide. So let's quickly make the extension. Let's quickly make an extension. Really, the only file that you need is the extension release file, and that is just because we share the DDI matching code. So you can fill it in with something like architecture, or you could fill it in with something more arbitrary. You will see that this looks suspiciously like an OS release file, and that is because they're supposed to work in conjunction with each other. And in addition to the extension release is basically whatever files that you want to put in, right? So we are currently working towards /etc, and then we add an additional myapp.conf file, and so that when you actually do merge it, then you will see myapp.conf. Now, this folder on top will work as is, but it is probably far more helpful and easier to herd if it actually is a single file, so you can do something like make /fs, or you can use something like GPT images, which we will also talk about later if there is time. And so to actually apply the extension, you use something like the systemd-confext tool, right? When you list it, it basically scans through a prescribed set of directories, and then it'll be like, hey, there's an extension here that I can apply. If you want to apply it, you run systemd-confext merge, and basically now /etc/myapp.conf will be available. If you run the mount command right after you run merge, you kind of get a sense of what's happened. Now remember, for overlays, we got to read it from the right to the left, right? So at the very bottom, you have /etc, right? That is your base etc that came with the file system. And then you have whichever extensions in the middle, plus some metadata at the very front. Now, one thing that is not incredibly obvious here is that if you have multiple extensions, then systemd-confext will set up all the overlays, will set up the overlay and then apply them all at the very end, which means that you get it all in the end, very atomic, no partial views as you mount more extensions, and that is like a nice side effect that you get with confext. So that was just a merge command there, but as you might be able to tell, quite a couple of things happen in the background. As you run the merge command, it has got to look through some prescribed set of directories. If you use the global confext command, then it's /run /varlib/etc confext. And then after you look through the directories, then you got to actually mount them, right? And so overlay FS is kind of like this meta file system, so someone has to do the actual work and actually mount them and do the dissection steps, the OS release comparison. And then finally, we build the overlay, which is what we were talking about at the very bottom in the last slide there, where you basically set up your base file system and then all the layers that you have in between, and then in the end, all of that get applied. So I'm happy to report that over the past 2 years, there have been fairly robust work done for all of them. So for example, you can now use them with specific services as well. So you don't have to use the big confext binary that gets it applied towards the entire file system. And then these steps kind of each build on top of each other, like vpick-ing and some CTO reload support that comes out in systemd-258. And I will talk about that in detail. So what if you don't want your extension to be visible by every single service out there? You might want this for security boundary reasons, or you just want it to keep things clean. Well, the good news is that very shortly after the 2023 talk, we've written more glue code to basically allow you to use them in a service file as well. Or you can use them in portable CTL and do the -s extension, and now both of these methods will now let you use confext images with them as well. And sort of building onto that, this builds on Leonard's work on vpick-ing. So what if you made a confext image, but you want to update it, right? You want to update the configuration file. Well, you have to either fix up your unit file to get it to point to a new extension, or on the host itself, you do a bunch of mad renamings in order to overwrite the file, and then you restart it. Well, with something like vpick, you can use this directory format that basically ends with .v, and within that .v folder, you put a bunch of new versions. You can keep adding into it, and then next time you restart your service or you reload the extension, it automatically picks the highest version. So even when you have a class-like extension images, right? Images, you still use the .v folder, right? You use the folder, and then it actually knows to pick from the image file within it. So this is nice because next time you restart the service, you always get the newest one. Now, notice I said restart there because when you set up a service, right, that is usually when you do the mounts. So that is usually your one chance to get all your mounts, get your extensions in place. But what if you don't want the downtime associated with the restart? It would be really nice if you could systemctl reload a service and have that pick up a new extension image as well. Previously, you couldn't, and now you sort of could. Now we gate this feature with notified reload services. This is sort of an arbitrary decision. The thinking behind this right now is that if a service is notified reload, they really bought into the whole systemd idea, and they will actually process SIG-hubs correctly, and they will and they will do a SD notify to tell us that they are done reloading. But in the future this might change. But with notify reload services, if you when you reload the service, it will look at the extension images that you have specified, and it will potentially vpick a newer version and then rip out the confex in the background and apply new versions for them. And this is really nice because it means that which means that if you implement reload correctly in your own program, you don't get any downtime anymore. This turns out to be really annoying to implement, so I wanted to spend some time to discuss this in detail. The intuition is that reloading should be pretty similar to restarts, at least on the surface, right? So you have to get the overlay FS that you set up previously, and you figure out what's the base etc underneath, right? Because that is your base layer, so you gotta get a reference to it again when you set up the new overlay. And then you basically stack on new extension images as well. And technically this should work, and that is what I thought in the very beginning. But then you quickly run into a couple of problems. Like, for example, how the heck do you refer to that etc again? Now you have an overlay on top of it, so when you refer to /etc, it is actually the overlay, not the one that is underneath, right? So you don't want to have an overlay on top of an overlay for no reason. So then you say, well, if I don't have access to the base etc, I'm just going to unpeel the overlay at the bottom so I can get the one at the bottom after unmounting. But now you ripped it out from the service that was using it. So you don't want it so that in the middle, while you were doing all of that, the service suddenly lost access to all of its extension, which is bad vibes as well. And then there are some other miscellaneous problems, like for example, the etc that the service is using might come from a root image, and it might actually be different from the etc, or it might be different from the host namespace where all your extension files are living. And so now there's also the issue of namespacing, which is a little annoying, and that will take some resolving as well. In the end, what really helped was Christian's 2023 blog post on mount namespaces, and we end up doing a little bit of surgery to get all of that to happen. So what do we end up doing? There ended up being two forks. The first fork is to the host namespace. Part of this is cosmetic. Part of this is to basically clone the namespace to make it so that in the very end, all of the file system stuff that we did just gets dropped. But then what is the more important thing is that we also have to fork into the target namespace, also cloning the file system there. That is the namespace of the service that we want to reload on. And by cloning the namespace, when we do a fake amount on the etc, when we do the amount on the etc, the actual service doesn't feel it, right? Because we basically just cloned it. And by doing an amount at that point, we can basically get access to the base etc, the naked etc that we needed. And then, in the end, it is the process of gathering all the FDs that you needed. So we open the extensions, get their FDs as well. And then in the end, we set up an overlay. Now, remember, you can, from this is the previous slide, you can see that you can actually just refer to file system by their file descriptors, which was really handy here because it means that you can, fetch the FDs of whatever that you unpeeled, and you can basically just pass them around between processes. And then in the end, you construct a new overlay and you do a mount beneath, and that will basically allow you to basically swap out the service without the it will allow you to swap out the overlay without the service feeling it. And then at that point, you send the SIG-hubs to tell it that it needs reloading. All right, that was a lot. So just to demonstrate all of these steps, all of these developments working together, I have a little demo that I'm going to ask you to suspend your disbelief for a little moment. So the other day I was taking the train from the airport, and it was stuck at the station. So, anyways, So say that this is your new job. Your new job is to run these departure boards at the train station, and I do this just so that we have something visual that you can look at. So you can look at the thing reloading. And yeah, this is just a mock-up. It is just a notify reload service that has a single confext extension. The confext extension contains some information about what gets shown on the GUI interface, and that is just a mock-up. It's not the real thing, of course. And this is just an example of a configuration file. So yeah, let's say that we want to make a new extension, which I will do here. So we have version 0.1, and we'll just make a 0.2 there. And we'll just change something here. We'll just, we'll change the destination to Bielefeld, which I'm told is the city that never sleeps. And let's make everybody go to platform 15. Oops. Oh, that's root, is it not? OK, and now if you run the systemd vpick tool right here, and I know that is very tiny, I'm sorry, you will see that when you run vpick, just run it on the .v directory, and it'll figure out that it is 0.0.2. And so that now, technically, when you reload, you should see the new content. Right? And you see that thing just updated without any issues, and I did not restart the service. It just reloaded. And by looking at the journal, in the journal I have it so that every time you reload, you just run the mount command again. You can kind of see what's going on, because in the original version, we refer to the run systemd stuff as the extensions were set up. But when you reload it, just for convenience, we actually use file descriptors to refer to anything, and that is the second line here, right? And so you can see that instead of /run/systemd, we just use fds instead, and that is showing the reloading code that we were talking about working. And yeah, this is just a little demo to show you what reloading might look like. Thanks to the hypothetical train company for humoring me. And just going back to the presentation, just before we wrap up, I just wanted to talk a little bit about some extra tips and tricks from using confext at work. So at Microsoft, everything is already an extension image. Each functionality used on the Azure host to run the VMs, they basically get run on our Linux system as an individual service, an individual portable service. So all of the images are hashed and signed. We use something called IPE in the kernel to enforce this. So basically, if you try to read the configuration file and it finds out that it is not on a signed and verified partition, it will not let you read it. And so, yeah, so technically for a single extension, you have to carry all of these signatures as well. If you don't want this to happen, if you want a little more convenience out of it, one thing that you can do is to use GPT images. And what this basically means is that for all of the files that you have to carry for variety purposes, you just DD them into a single image. So you make /fs to payload as we previously shown. You generate some extra hashes and signatures, and then you just DD them into a single file, and you basically add partition labels into them. So yeah, so later on, the system will be able to tell which part is which. I found that the systemd test suite, the integration test suite, actually has a surprisingly helpful end-to-end demonstration of how all of this is done. And so I will upload the slides later so you get the link to it, but it is in test50dissect.sh if you want to pregame it and look it up. Also, a theme that you will see in the next few talks as well, which is you make the confext extension image, you made the sysext extension image. How are you going to apply it? One idea at work, we just kept it all within systemd, so we don't really write any new tools for it. You can basically use something like path units to watch over the file system for you, and and if it sees a new extension in some predetermined folder, then it will just run reload on it, and then the entire systemctl reload handling code takes over, and it will just reload the extension images under the hood for you. And yeah, this is really helpful because all of the individual services running on the Azure environment are owned by other teams, right? We are a fairly small team. And just by using something like path units, we can let them just drop in any files that they want, drop in any extensions into their own directory, for example, to change the log level or whatever. And we never actually have to give them access to the Linux system itself, which is really helpful. So that is just one idea to trigger a reload as new extensions come in. And yeah, still a very young project. There's a lot more to do. One example that I mentioned earlier was that right now this is gated for notify reload services, but if you have other scenarios, you might be interested in adding more nodes in order to get that reload code path to kick off. Rollbacks is the next major thing to do. What if you dropped in a new config file? There's a syntax error to not load, to fail. Be really nice if you can just roll back to the next version. To roll back to the previous version. Now that you have a tool like vpick that is supposed to handle versions for you, and yeah, all of that is tracked under a single GitHub issue on the systemd repo. If you want to keep in touch with how confext is doing. And yeah, that is all that I have so far.
Thank you. Questions? Yeah. We have time for one question or two questions. Any question? Yes.
Hi. You mentioned LUKS2 encryption is not yet supported. Do you use it in production and have a workaround for it, or how do you use it currently to supply confidential data?
So we currently don't use this. So this will be a future to do. I know someone actually might have already opened a GitHub issue about it, but no, it's not something that we do right now.
I think there's for encrypted, you mean? There's a PR for encryption, I think.
Oh yeah. Oh, it's okay. Cool.
Yeah.
New development.
Any other question?
Did you ever get into the need to validate config before applying it? Let's say something delivers configuration for a service, and that config can break your service.
Yes.
Is there a way to validate config before applying it, and if it's not valid, then refuse to apply it?
I don't think so, and that is something where the rollbacks will be really helpful. Hopefully this is something that can work in conjunction with how your service handles the law. Like when it gets the SICUP and tries to reload, hopefully it will have a way to work with systemd to make sure that it can tell it to roll back without the entire service actually breaking and the process exiting. But yeah, that is a very good observation that it is fairly firmly future work. Yeah. Otherwise, in the short term, I think best to just have support some dry run, loading an arbitrary config file, and yeah, work that as part of your workflow to make sure that it's validated.
And one more question, if I understood you correctly. You introduced new type of the service, notify reload. How does it overlaps with previous, like simple exec notify?
Yes, so it's not a brand new service type. It's been in there for a while. Notify reload, in addition to the notify, additionally uses the systemd-sd-notify tool to basically say like, hey, I'm starting to reload. Hey, I'm done reloading. Whereas if it's a simple notified service, it is just guaranteed to handle SICUPs. So it doesn't do any additional thing to system.
So I'm still confused.
Yeah.
You put service type notify, right? It's for SD notify. In your case, it's notify reload. How does it behave in terms of execution? Does it have to send SD notify, or am I missing something?
Yeah, so the extra thing is the part where it talks to
Okay, so
systemd.
it's still notify service. It's not, I cannot use a notify reload with a simple service. I have to implement all that SD notify functionality for the regular notify and get reloads on top of that, right?
Yeah.
All right, how are we doing with time? We are late. Unless there's a very quick question, I think we should close it and go for lunch. Cool. Thank you again, Maya.